Hi, everybody. Good afternoon, good morning, wherever you happen to be. Thank you for taking the time to join us for another Azure Data Academy session. Our series here has been focusing on Azure Database for MySQL Flexible Server. All of our content is up at aka.ms/ada. So if you'd like to see some of the past sessions, please visit that page and check it out. So today we're going to be talking about flexible server and migration. We've got with us today, of course, we've got Avnish Rastogi from the product team, and we also have today with us another special guest of Jim Toland, who is also a engineer on our MySQL engineering team here to help. These guys are going to help field some questions that we've got. Now, if you're watching this and you have a question for us, you can leave the question in the chat if you're watching this live, or if you are watching this through our repo or playback on demand, you can reach out to us using our aka.ms/ada-feedback. That's for our Azure Data Academy feedback. Give us a question and we'll be happy to answer that. Okay, as mentioned, our content is at aka.ms/ada, and our series here has been focusing on MySQL Flexible Server. We have some content as well on Postgres, Cosmos, and SQL Server. Some of these sessions are currently slated to come in a short amount of time. Some of the Postgres ones are already there. If you have sessions you would like to see, let us know, because we've gotten some suggestions and we've already incorporated that into the Data Academy, or the Analytics Academy sessions rather, and we're happy to take those suggestions and go from there. Again, feedback is aka.ms/ada feedback. And so we can just move right into today's session. I'll just turn it over to Avnish to jump right into it.
Yeah, no, thank you, Brian. Migration is one of my favorite topics, as I work with the customers to help them in migrating their MySQL workload from on-premise or from different cloud providers to Azure. And today, as Brian mentioned, I have Jim, who is going to support me in this presentation. So Jim, thank you very much for joining the call.
Glad to be here.
So as we discussed in the previous sessions, in Azure Database for MySQL, we have two deployment options: Flexible Server, which was GA'd last year in November, and Single Server, which has been GA'd over the last 3.5 years. And we had a huge adoption of different customers across different verticals. And now with Flexible Server, we are excited to work with customers for the migration to Flexible Server. So before we do deep dive into migration options, one of the we want to briefly talk about why customers are migrating to cloud in general, and further why customers are adopting open source technologies. So there are multiple factors which influence customer decisions to migrate to cloud. And it also affects the timelines on how soon they need to migrate to cloud. So data center contracts expiration is one of the key factors which influence customer decision to choose cloud. So if customer has a data center lease expiring coming soon, then they look at the options whether they should renew the lease or should they migrate to cloud. And based on the timelines, it also influences on how soon they need to migrate to cloud. And other factors include the software or hardware refresh recycle that typically affects different applications. And strategic decisions like merger acquisitions also play important roles in how they want to integrate these new acquisitions into their existing environment, whether they do the integration on the on-premise environment or migrate them to the cloud. So all these factors really affect customer decision to migrate to cloud. Now, adoption of open source technologies also depends on multiple factors. And a couple of important factors we heard in our discussions with the customer is the multi-cloud strategy. More and more customers are adopting multi-cloud strategy. And with open source technology, it gives them flexibility to to migrate workload from one cloud provider to another cloud provider. Other factors we have seen is the compliance or application innovation. With cloud, customers have flexibility to innovate much faster because new technologies are now available on cloud first before they're released in the on-premise environment. So migration is one of the important component in customer journey to cloud. And depending on the workload, there are three components in every single migration. One is the discovery and assessment. So if you're migrating from on-premise to Azure, first thing is to understand how many database instances, or in this case, how many MySQL instances you are trying to migrate to cloud. What are the different versions of MySQL you are running on-premise? And what are the different applications these MySQL instances are supporting? How much downtime these instances can tolerate or applications can tolerate? And all these factors really feed into your migration strategy.
Avnish, if I can ask, so
yes, please.
Coming from the SQL Server world, we have a lot of documentation on migrating SQL Server. For SQL Server in the cloud, we've got several different options, right, from VM and PaaS, like Azure SQL Database for SQL, managed instance, right? So there's a lot of options there. And a lot of our documentation talks about different ways to mitigate compatibility issues and to discover them. For example, with SQL, using cross-database joins is going to be a problem for Azure SQL. So, what's the best way in MySQL Flexible Server to do those kinds of assessments for both compatibility but also performance? How do we know that we're not going to hit a compatibility issue or a potential performance issue to make sure that the database is right-sized?
Yeah, no, very good question, Brian. And you are right that assessment is very important factor in the migration journey. So in Azure Database for MySQL, we run Community Edition. So if customers are migrating from on-premise Community Edition to Azure Database for MySQL, then there should not be any issue on the compatibility side. That being said, because ours is a PaaS service, the permissions customer have on-premise would be different than they would have in our PaaS environment. So what we have seen in cases working with different customers, that sometimes they create database objects using super user privilege. And that level of privilege is not available in Azure Database for MySQL. So that's one of the things which is very important to do from the assessment point of view, to identify if there are any database objects owned by the super user in their on-premise environment. And if that's the case, then they have to switch those objects to a non-super user privilege account. Second is the collation. We need to make sure that collation align with the on-premise and Azure Azure target instance as well. So there's certain things which we need to keep in mind from the assessment point of view. And all those things have been documented in our public facing documentation, and that what are some of the things which they need to keep in mind as they do the migration from on-premise to Azure Database for MySQL. Now, performance is always very tricky because on-premise, sometimes customer has local disk to the compute. But in our case, compute and storage have been decoupled. And sometimes CPU performance may vary from on-premise to cloud as well, even though number of cores might be same. So what we suggest to the customer that definitely do the POC, do the performance testing as well as application performance, application functionality to make sure everything goes smooth before they do the production migration. So hope that helps, Brian. But if you have any follow-up questions, clarification, let me know.
That's great to hear. And it sounds like the biggest blockers are potentially really around permissions. Our SQL Server world is very similar, by the way, with IOPS, right, being the main one of the main things to watch for in gauging performance, if you're running locally and you've got a large, fiber channel SAN array or something with incredibly low latency and high throughput, it's just a different model in the cloud, and you have to account for that, right? And that's why we have the different performance tiers. So it's something that sometimes doesn't come up unless you test for it, right? Because you could move something into the cloud, and if you don't do the appropriate load testing, it might not expose whether or not you've got the right performance in place to support an application of a certain load. Now, with SQL Server, we would use something like Data Migration Assistant, DMA. Any specific tooling, or I guess tooling or paths to evaluate?
No, so from on-premise to Azure Database for MySQL, we have some custom IP which we put together, which we built. So as we work with the customer, we share those IPs. Nothing is published publicly in our documentation right now. And one of the reasons being, like I said, Brian, that because we run the community edition, so there is not a huge compatibility or any compatibility gap, except the privilege kind of thing. And the privilege, if you look at the best practices, it's not a good idea to create database objects using super user permission or SA account in case of SQL Server. So it's always good to assess and identify these kind of database objects which are owned by the super user and switch it to the regular account. So it's a corrective action for the customer as well as they migrate from on-premise to Azure environment.
Oh, that makes sense. No, great explanation. Thank you.
And on the performance side, one of the key advantage in the cloud is that let's say they migrate to cloud and they run into any performance issue and need more capacity. It's just matter of scaling up the cloud instance in Azure or any cloud. You can scale vCore, or you can add more memory. There is a lot of flexibility in terms of scaling the environment in cloud.
Now, and I know we're not technically diving into scalability here in this presentation, but when we scale a MySQL Flexible Server instance, that's an online operation, right? And there's probably a slight hiccup or when connections have to change, or how seamless is it when we do a scale operation?
Yeah, so it depends on a couple of factors, especially if your database has heavy activities going on during the scale-up operation. That's something customers should keep in mind, that it's always good to scale the environment during a quiet time, because there would be few seconds impact on the application, and application lose the connectivity during that time. So we always recommend customers to make sure that application has a retry option. So when this scale-up operation happens, application is able to retry and connect successfully.
No, that makes sense, and that's definitely a best practice, regardless of the platform. So,
yeah,
agree.
At least cloud native application has always this retry options, but for the legacy application, that's a challenge. So if applications are, if customers are doing these scale operations during the quiet period, the impact would be very minimum. But they have to reconnect their application to the database instance if they don't have any retry option. So that being said, like I said, one of the important component in the migration journey is the assessment of their on-premise environment. And once you understand the compatibility gaps and all those things, and you refactor your on-premise environment to make sure that there is a 100% compatibility, then second question is, okay, how do I migrate these instances from on-premise to Azure? Now we have a couple of options depending on how much downtime your application can tolerate. So if application is not critical and database instance is not huge, then there are two options for the offline migration. One is Azure Database for Azure Database Migration Service, which you can use to do the migration from on-premise to Azure. It's an offline migration. So your database instance would be down during the migration. And second is the dump and restore. So dump and restore is like backup and restore. Again, this is also an offline operation. But if your application is critical and cannot tolerate a lengthy outage, then third option is data and application. And so it's a mix of data and application and dump and restore. In this case, we do the initial seeding of your database instance into cloud using dump and restore. And once we have the initial seeding in place, then we set up the replication between your on-premise environment and Azure. And that allow us to keep your target instance in sync until you are ready to do the cutover. So we have done multiple migrations successfully with as less as 15 minutes outage. And that includes application connectivity change, testing, quick testing to make sure everything is working fine before they go live in Azure environment. That being said, sometimes customer require little bit lengthy application testing. So it may take a little bit longer to do the final cutover. But from the database perspective, we can do the cutover in less than 5 minutes. And we have done this with multiple customers. And towards the end of the presentation, I have one example where we did the migration from AWS to Azure in 20 minutes outage, and that including updating the connection string, application testing, as well as the switchover. So once you are up and running in Azure, then sometime you have to do the final fine tuning to make sure that your database instance has the right sizing to meet your application performance SLH. And as we mentioned a few minutes ago, you can always scale up and scale down. There will be a few seconds interruption. So we recommend customer to do it during the quiet period, or have a 5 minutes outage or something like that to make sure that there is no impact on the application. But if your application has the retry option in place, then your application would be able to connect successfully once scale of operation completes. So these are some of the migrations options we have to migrate from on-premise or from cloud providers to Azure.
What I really like about that approach is that it kind of gives you a way to abort, right? It was particularly with data in that you can do the initial copy of a database and then start feeding in data, the delta, right? The new changes, and obviously, ideally, you throw a switch at some point, right, to complete the migration, but you're not committed. You can be testing, you can be looking at it, making sure everything looks right. If for some reason maybe you're doing a dry run, or maybe you see a problem, you can abort at that point because nothing's actually been migrated from an online standpoint. You know, you're still copying the data, but it's you can abort actually changing the connection strings and whatnot just to make sure. So as opposed to an offline migration, right? As soon as you shut down your app, you know, however long it takes you to actually copy and move the data and then restore it and get it up and running, you know, the clock is running at that point.
Absolutely. And with this online or data and replication migration option, it gives customer a lot of flexibility. Plus, while we are doing this replication, the target instance in Azure is always available in the read-only mode. So yeah, you cannot test your DML transactions, but if you want to run some read-only queries to test the performance or to test different things, at least your database instance is available in the read-only mode. So like I said, it gives a lot of flexibility using the data and replication migration option. So we have different flavors from the migration perspective. Obviously, one of the key use cases from on-premise to Azure, or from AWS or GCP to Azure. But as we mentioned in the beginning, we have two different deployment options right now: single server and flexible server. So we have a lot of customers who are doing the migration from a single server to flexible server. But regardless of the source, whether it's on-premise, AWS, GCP, or from single server to flexible server, the approach we presented here can be applied in all the different use cases. So dump and restore for the offline migration, and dump and restore plus replication is for near zero downtime migration. So one of the thing I want to highlight is that so in Azure, in MySQL, there are two ways to do dump and restore. One is MySQL dump, which is a single-threaded operation. So if your database is small, less than, let's say, 50, 60 GB, then you can do MySQL dump. But if your database is, let's say, over 100 GB, then we recommend to do my dumper and my loader, which is a which you can have multiple threads to do your backup and restore. So for example, if your VM where you are running these operations has 32 vCore, you can have 32 threads in parallel to do the dump, and same thing you can apply 32 threads in parallel to do the restore operation. And on this slide we have a link which you can use to identify which tool would be the right tool to do the migration from on-premise to Azure. So for example, we provided these different guidelines. So offline migration, if your database is 1 terabyte or less. And here you can see the tutorials as well as best practices which you can use to do the migrations. And like Brian mentioned, if you have any questions, you can always reach out to us. But this is a very good tool which you can use to, or the link which you can use to identify what's the best way to migrate. What are some of the best practices and the tutorials we have provided here. So for example, these tutorials briefly talk about the migration using the Azure Database migration service. Then we have this single server to flexible server migration option. And we also have this tutorial to do the migration with almost zero downtime. So here we are talking about what are the different prerequisites you need to keep in mind, networking requirements, as well as how to configure the data and replication from your on-premise to Azure environment.
This is great info. In fact, I'll make sure that all of these links, depending on how you're consuming our session here, I will have them in our repo, which is the aka.ms/ADA, or if you're catching us in the webcast, we have a file section where we can where we'll have all the slide deck and whatnot for you to download. So depending on how you're consuming this, we will have all of that content, and I'll put all of the hyperlinks that you reference here in there. So it'll be easy for everybody to just jump right into those tutorials.
Yeah, this will be a very handy slide for the partners or customers because it really walks through what are the different tools, how to select the right tool, and tutorials if somebody wants to have a jump start on these migration tools. In addition to that, there are certain parameters which we recommend to keep in mind as customers do the migration from on-premise to Azure Database for MySQL. So even though we are saying here single server, but same list of parameters would apply for the flexible server as well. So something to keep in mind as we migrate your on-premise environment to Azure Database for MySQL, because these parameters will help us in improving the load performance to Azure. So here we have an example of what are the commands you can use to do the my dumper. So in this case, my dumper, you specify the host name or the source server. You specify the username, password, and the directory where the dump would be stored. Now, rows equal to, that's another parameter to keep in mind for my dumper and my loader. So if you have a large table with millions of rows, then this parameter will break that table into small chunks of 10,000 rows. And depending on the number of cores on that machine, you will have that many threads in parallel to speed up the loading, backup and restore of your table. In addition to that, you can also compress your backup files. And this is basically saying that we want to exclude MySQL, information schema, performance schema, and sys. So these are the 4 system databases which we don't need to do the migration. So it will basically back up all the user databases, and then this is the restore command you can use to restore backup from this my dumper into Azure Database for MySQL. So host in this case is the target for Azure Database for MySQL. Then you specify the username and password, directory where you have the dump, and the queries per transaction, and a couple of other parameters. And threads is the number of threads you want to have in parallel to do the load operation. Once you have the initial seeding in place, then there are a couple of procedures which we are exposing to set up the replication. So you do the change master, you specify the source database instance, the username and password, and the bin log file and the bin log position. And once you have the change master in place, then you start the replication. And all that information has been captured in all the details in the links we mentioned in the previous slide in the tutorial.
For the batch size, I know you mentioned that they're depending on performance and whatnot. So you have in that case for dumper, my dumper, you have 10,000 rows. Is that somewhat arbitrary, or is there a good formula to go by in determining this batch size?
Yeah, so the logic I use here, Brian, so let's say you have 10 vCore machine. So that means you can have 10 threads in parallel. Now, if you have literally lot of tables with millions of rows, you can probably have rows equal to 100,000. So that will allow you to basically break this million rows into roughly 10 chunks. It really depends on how many tables have that large number of rows, number of vCores on that machine. So there's some thinking goes into that because if you really want to have, you really want to leverage the computing as much as possible to speed up the backup and restore operations. So this is one of the architecture, the reference architecture we used to migrate one of the customer from AWS to Azure MySQL. So obviously, we did the snapshot of AWS Aurora to AWS DB snapshot. Then we took the MySQL dump from the AWS EC2 machine and copied that back up to Azure Database, Azure VM, and did the restore into Azure Database for MySQL. And once we had the initial seeding in place, then we set up the replication between EC2 to Azure Database for MySQL. Now, in this case, customer also had the requirement to do the rollback in case something doesn't work out after the cutover to Azure. To support the rollback strategy, we set up the reverse replication after the during the migration from Azure Database for MySQL to AWS EC2 machine. So cutover strategy or the rollback strategy was to fail back to MySQL instance running on EC2 rather on AWS Aurora. And that's something we did a couple of POC to make sure that we identify all the steps and document everything and make sure everything goes smoothly. But during the production migration, we were able to complete everything in less than 20 minutes outage. And the database instance in this case was roughly 1 terabyte. So it's not a small instance we did the migration, but in 20 minutes, we migrated to 1 terabyte successfully.
Wow, that's great.
Yeah.
No, that's fantastic. That's, it sounds like a manual, like this architecture is somewhat of a manual read-only replica across cloud, right? Because you start with it being online in EC2, with the flexible server being a, essentially read-only target that's there, and then vice versa, right? You throw the switch, and now the roles are reversed, and you still, you have the data in sync, and gives you that option to fail back if you need to. So
yeah, I mean, fortunately, customer didn't have to do the failover, but customer had this reverse replication running for at least 2 weeks, just in case kind of a situation. But everything went really well, and customer successfully running on Azure today.
This is great, and one of the things that I think this is probably already answered in that documentation, some of the documentation that you had earlier, but I want to call out if there are specific best practices that we have for partners and customers to be using. Was that in one of those links that was previously mentioned?
It was in one of the link, I believe. So if you look at this link, best practices for migrating large databases to, so we try to document all the learnings we had from different migrations. So, but like you and I mentioned in the beginning of this presentation, if there are any questions or something, definitely reach out to us. and we are happy to partner with the customers or partners to support them in their journey to Azure.
Fantastic. That's great. Thank you so much. And thank you for taking the time to walk through this. And as I mentioned, I will have all of these links that we've been talking about in our repo where I could easily list them. I'll make sure that they're all there so that you don't have to try to scramble and copy URLs from Avnish's desktop here to get to these pages. We'll have those links available for you to reference. And as a reminder, this session, this is the roughly the third in the series that we've got. We have several that we've been doing. I don't quite know the exact order, if this is 3 or 4, or we're still working that out. But at the end, near mid-July 2022, we're going to have a roadmap session and then also Q&A with hopefully Jim and Avnish will both be there, but we're going to be taking questions live. We're not able to record that session. So if you have any questions and want to get a sneak peek at the roadmap, we invite you to check it out and please join. If you have questions that you would like us to address, you can also submit those through our feedback forms that we've already mentioned. If you would like to do that, feel free. That way, we'll make sure that we're able to address them in the webcast. But in the meantime, thank you very much, everybody, for taking the time to attend today, and thanks to Jim and Avnish for taking the time also to present the material. It's greatly appreciated.
Thank you very much, Brian. Thank you, Jim.
Yes, appreciate it.
Take care, everybody.